Hello students, and welcome to your finest, easiest and the learning channel producer classes, and it is more conceptual as BSc. For today's class we are actually uh, clear your concepts through numericals, different types of numericals. As I know, before 3 classes I have completed uh, the concepts of moments, it is units, and what is the convention used, that is when we take the positive or negative uh, moment of force. So for today's class, and it is all about the numericals, and that clear your concepts about movements stronger part. So for today's class, uh, we choose a particular book, Selena or the Concise Physics, and go through all the numericals. So please take your copy and pen and go through a new process that is given by me, this producer, copy pen method. So let's get out your copy and pen. Take your copy and pen and clear your concepts. Thank you. So students, I repeat again, all the concepts given in the previous class, there is the numericals class for moment of force, and we know that the moment of force, that is tau, we can denote it as tau. So this is a Greek alphabet, and this is tau, T-A-O, tau. This is a symbol like I repeat the different times, that is we can write this as tau. So tau equal to force into distance. Distance means it is always perpendicular distance, and so moment means turning effect. That is when a body is not free to move, then if we apply the force, then it turns in a specific direction. And if suppose if we take that particular figure, suppose this is the pivoted point, and if we apply the force here, then it turns in the anti-clockwise direction, and when it turns in the anti-clockwise direction, then we can take it as positive. But when it is in the clockwise direction, then we take it in negative form. And so that particular formula is used here, tau equal to F into D. Okay students, F into D, tau equal to F into D. And so the unit of it is, unit for force it is Newton, and for distance it is meter. So Newton meter, or we can write this is dyne centimeter. This is dyne, dyne centimeter. This is CGS unit. This is CGS unit, CGS unit, and this is SI unit, Newton meter. This is SI unit. So these are the absolute unit. These are the absolute unit, and if we take kg force into meter, kg force, it is a gravitational unit into meter. So then this is the absolute unit, and the substitute unit is kg force into meter or gram force centimeter. But if only for weight or force is given, then the each and every numericals, there is a specific unit, that is kg force or gram force. And then you think that this is only the gram force or kg force. If it is given, then you imagine or think that it is only the unit of force. Okay, so first is tau equal to FD, then Newton meter. These are the important point. Tau equal to F into D, Newton into meter, and gram force. Most important figures or equations or units that is used in every numericals, and the particular convention. Anti-clockwise moment means positive, and clockwise means negative. There is the convention. It is sign convention. It is called sign convention. used, sign convention. So let's take an example. Suppose it's a numerical number 1, and the it is given the moment of force is 10 Newton about a fixed point O. So when a numericals is given, it is always written as the moment about a fixed point. So question number 1, it is moment about a fixed point. Suppose this is a fixed point and it is pivoting point. So this is the point, and 10 Newton about a fixed point O is 5 Newton meter. Suppose here it is given a force F, and that is equal to 10 Newton. That is equal to 10 Newton force, and the perpendicular distance is suppose d, because the formula is tau equal to F into t. So the moment of that particular force about O is moment tau. Here tau is given, tau equal to 5 Newton meter. 5 Newton meter. So this is tau equal to 5 Newton meter. 5 Newton meter. So again read the numericals. Calculate the distance of the point O from the line of action of force. Calculate the distance. So you have to calculate that particular distance. That is line of action of force, means this is the particular line of action of force. So from O you have to calculate that particular line of action of force, that is the distance, that particular distance. So F equals to, here given this is given, so given F equals to 10 and tau equal to this, you have to calculate d, you have to calculate. So from the definition of moment we know that Fd tau equal to Fd, so d equal to tau by F, or tau is given 5 Newton meter, 5 Newton meter by force 10 Newton. So Newton cancel each other, and 5 and 2 is 10, so 0.5, half means 0.5, so 0.5 meter is the distance. So check the answer. This is 0.5 meter. So the answer is 0.5 meter. So this is the particular concepts, and when we are going to calculate each and every numerical, then concepts are stronger and stronger and then stronger. So question number 2. For question number 2, a nut is opened, and we always use to open a nut, a wrench is used. So this is a wrench, and we all know the particular shape. This is, if this is a nut, suppose, and this type of shape is governed particularly. This is this type of machine, lever machine or lever is used to open the nut. And if we the question is, a nut is opened by a range of length. So the length, if this is a fulcrum, so the length of the range is here given, a nut is opened by range of 10 centimeter. So this is 10 centimeter of length, 10 centimeter, and if the least force required is 5.0 Newton, so the least force F equal to 5.0 Newton. 5.0 Newton. What is 5, or what is 5.0? Question mark. Is 5 or 5.0 is same or not? Think about it, and then last of all I answer your questions. So F equal to here given 5.0 and F equal to 5. Find the moment of force needed to turn the nut. So in that particular numericals you have to calculate tau. So tau equal to F into T. So F is 5 Newton and T is 10 centimeters. So you have to convert it in SI unit. 1 centimeter equal to 1 by 100 meter. So 1 meter equal to 100 centimeters, since you have to divide that particular value, and this is 5 by 10, that is 0.5. This answer is also 0.5. Yes, this is 0.5, but the unit is Newton into meter because it is tau, moment of force. So the question number 2 is, a nut is opened by a range of length 10 centimeter. If the least force required is 5.0 Newton, then find the moment of force needed to turn the nut. That is 0.5, and answer is here 0.5 Newton meter. Okay, so the question number 2 is clear, I think. For the next questions, a wheel of diameter 2 meter, a wheel of diameter 2 meter. So that particular wheel of diameter means from A to B. From A to B, the diameter is 2 meter and force is given 2 Newton forces applied at B. Calculate the moment of force about the center. When you have to calculate the force about center, so that you can take that particular distance O to B. So O to B is, and the total is 2 meter, so total diameter, so the radius is half meter, 1 meter. This is 2, so this from that particular distance it is 1 meter, and so 2 into 1 is 2 meter, so answer is 2 Newton meter. Why it is clockwise? Because when you apply the force at that particular point, then the wheel rotates in the clockwise direction. So the moment is clockwise, means it is negative, so you have to write here a negative sign. This is negative, clockwise. And if we take the moment at about A, then the total distance is 2, so 2 into 2, 4, so 4 Newton meter is the answer. So question number 3 is completed. Yes, it is completed. So next questions, question number 4. Question number 4, the diagram in 1.33 shows two forces, F1 equal to 5 Newton. Yes, it is 5 Newton, and F2 is 3 Newton. Yes, it is 3 Newton, and acting at points A and B. Yes, A and B of the rod pivoted at a point. Pivoted means this is the fulcrum. O, yes, O is the fulcrum, and such that OA equal to 2 meter. Yes, OB equal to 5 meter. Oh, yes. And then calculate moment of force F1 about O. F1 about O. So you have to take that particular distance. So multiply 5 into 2. 5 into 2 means 10. So first answer is 10. And if this force act along this direction, then it rotates along that particular. This is arrow. So along this, when this force act, then it is in clockwise, and this is anti-clockwise. So this moment is positive. So moment of force about F1 is 5 into 2, 10. So 10 is the answer, 10 Newton, and this is anti-clockwise. And the moment of due to the force F2 about O, that is 3 into 4. So this is clockwise, because when this force acts in these directions, then the B point downwards. So this is clockwise moment. So this is 12 Newton. 3 into 4. This is 12 Newton clockwise. And total moment of the two forces. This is the vital point. Total moment. So 10 Newton meter. 10 Newton meter. This is the first moment about O, and this is anti-clockwise. So anti-clockwise means positive. And for the next, this is 3 into 4. 3 into 4 means 12. But 12 in clockwise. Clockwise means negative. So clockwise. So if we add this one, then we get 2 Newton meter. So the 2 Newton meter, but this is positive. Positive means anti-clockwise, and negative means clockwise. So the answer is clockwise, because clockwise is this particular value is bigger than that value. So the answer is 2 Newton meter clockwise, or you can write minus 2 Newton meter. You can write minus 2 Newton meter or clockwise. Okay, so 2 Newton meter clockwise. Is that clear or not? I think this is clear. The next one is 5, and two forces each of magnitude 10 Newton act vertically upward. 10 Newton. Two forces, this is 10 Newton, each of magnitude, this is 10 and this is also 10. Yes, it may be couple. When two equal forces acts and this is the perpendicular distance, then the couple is any one of the force into perpendicular distance between the two forces. That particular derivations I completed for the before classes. So you have to pause the video and go to the previous class and derive that particular formula. So two forces 10 Newton and 10 Newton acts between the parallel distance 4 meter, and the two forces each of magnitude 10 Newton acts vertically upward and downwards respectively at the two ends of the uniform end rod of length 4 meter, which is pivoted at O as shown in, yes, it is shown in, and determine the magnitude of the resultant moment. Resultant moment. So what is the resultant moment? Resultant means if I calculated separately, suppose the moment for 10 Newton force above 2, then you have to write from that particular distance is 2, so 10 into 2, 20 Newton meter, and this is arrow is upward, so it is clockwise, and this is downward, so it is also clockwise. If it is in the upward direction, then it is anti-clockwise direction. Suppose the two arrows are upward, so this arrow can turn that particular direction, but this is opposite direction. So upward means clockwise, upward means anti-clockwise. It may be, you have to see it properly, conceptually, and determine this is clockwise moments or anti-clockwise moments. So this is clockwise, but this is anti-clockwise moments, and the total distance is 4 meters. So from O to this one is 2 meter, so 2 into 20 Newton meter, and this is clockwise, so clockwise means negative, and this one is 10 into 2, so it is also minus 20 Newton meter because it is also clockwise. So minus 20 minus 20 minus 40 is the answer. So minus 40, you can write minus 40 Newton meter, or you can write 40 Newton meter clockwise sense. So it is so simple. So the answer is 40 Newton meter and 40 Newton meter clockwise. Is that clear? I think it is clear, and go to the next one. Question number 6. So figure 1.35 shows two forces and each of magnitude 10 Newton. Yes, it is 10 and it is also 10 Newton, and this is the line of action. Along which a force of 10 Newton acts, and shows two forces each of 10 Newton and acting at the points A and B at a separation of 50 centimeters. So there is the separation, 50 centimeter separation in opposite direction. So calculate the resultant moment of two forces about the point A. So the total distance is here it is 50 centimeter. 50 means 50 by 100, that is half meter. You have to divide it with 100, then half meter is the distance, total distance. So calculate the resultant moment of the two forces about the point A, about the point B, and about the point O. It is a more conceptual question. So if we draw it like that, suppose two forces act here, and it is here, two forces. This is the line of action of force, and this is the particular distance, that is The total distance is half meter, 50 centimeters. So this is 25 centimeter and this is 25 centimeter, and this is 10 Newton force. So this is 10 Newton and this is also 10 Newton force. So A, B and O. And if we calculate about O, resultant moment about A, about B or about O, but this is the resultant moment. So when we calculate the moment about A, think about a particular situation. Suppose, and this is a pen, this is a pen, this pen is here. Suppose this pen is here, and if we and I want to rotate it with a particular force. So when I applied that particular force like that, then it is rotate or not? It is not rotated. It doesn't. Why? But when we apply this force along this direction, and along this direction, then it also goes through a particular distance. But if this particular point is pivoted and we applied a force here like that, then it rotates. So for rotation, we have to apply a particular force in perpendicular distance or along any other angle. If we applied a force along this direction, then it also rotates. But if we applied a force along the axis, then it can't rotate. So when we applied a force along that particular directions, so this particular force cannot rotate that particular body, but this force can rotate that one. So the moment of force about A, when we calculate moment of force about A, then we multiply force this one and that particular distance. So moment will be for that system, that is 50 by 100 meter into 10 Newton. So this is half into 5, half into 10, that is 5 Newton meter. Okay. But when we calculate the moments about B, then we take that particular system. So this is also 10 Newton into 50 centimeter. So this is Newton meter or 5 Newton meter. But if we calculate the force about O, then this is a system and this one is another system. So for that particular body, it is 10 into 25 by 100, and it is in the clockwise sense, and all the moments are clockwise, plus this one 25 by 100 into 10. So this cancel this one, 5 5 is 25, 5 2 is 10, 5 by 2 plus 5 by 2, this is also 5 by 2. So 2 into 5 by 2, so 2 into 5 by 2 means 5 Newton meter. So this is also 5 Newton meter. So when you calculate the moment of force about that particular point, then it is gives the answer 5 Newton meter. This is also 5 Newton meter and this is also 5 Newton meter. Okay. So if we go through an example, suppose this is the steering, and you want to rotate it by applying a force here with one hand, then what is the moment? And if we applied a force here with your left hand, only one hand, then what is the moment? And if we applied a force this one and this one with our both hands, then what is the moment? For the three cases, the moments remain same. That's the concepts. So it is a terrific the questions is too much easy if we go through a numerical process, but if we take this as in conceptual, then it is a very most important concepts. And we go through the next numericals, that is 7. Yes, a steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces, each of magnitude. So all the numericals given here are taken from all the relative life. And a steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces, each of magnitude 5 Newton. Draw a diagram to show the applications of forces and calculate the moment of the couple. So if we consider that this is steering, and if we want to rotate in anti-clockwise, so this type of force is required, means your right hand gives a force along these directions and left hand along these directions, and this is the perpendicular distance between the equal forces, that is given here 0.5. so simple it is, you have to multiply these and this one, 5 5 25, so there is a point, so 2.5 is the answer. So simple question. This is the concepts of this is the concepts taken from moment. So for the next questions, we go to the next questions. A uniform meter rule is pivoted at its midpoint and a weight of 50 gram force is suspended at one end of it. Where should a weight of 100 gram force is suspended to keep the rule horizontal? So it is a meter rule type questions. There are different questions like that. Question number 8, it is a meter rule type. So this is a meter rule. This is a meter rule, means it is a 0 and then 10, 20, 50, and this is 100 centimeter. So 100 centimeter mean 1 meter. So this is meter. And this is obviously it is 50, 25, 75, and then 100. Yes, this is meter rule. And so the questions is question number 8. A uniform meter rule is pivoted at its midpoint. Midpoint means at 50 centimeter. At 50 centimeter, it is pivoted at 50 centimeter. So it is a knife edge type symbol. Knife edge means the indicates the sharpness of the knife, edge of the sharpness of the knife. So 8, a uniform meter rule is pivoted at its midpoint and a weight of 50 gram force is suspended at one end, and there is a force 50 gram force. So gram force is a unit of this is gravitational unit of force, and so 50 gram force is suspended at one end. Where should a weight of 100 gram force be suspended to keep the rule horizontal? To keep the rule horizontal. And so if this is a 50 gram force and 100 gram force, so suppose we applied a load of 100 gram force here to balance that particular rule, 100 gram force. It is this type of numericals is called principle of moments, so that this particular force can rotate that system in that particular direction, that is clockwise direction, but this force rotate the system along anti-clockwise direction. So when the clockwise and anti-clockwise direction, anti-clockwise moment is same, then you can say that the system is in equilibrium. So that particular distance is 25 centimeter, 50 centimeter, sorry, overwriting is the stupidity. So cut this clearly and then write here 50 centimeter. So this is 50 centimeter, and this is x, because we have to determine that value. So the moment is 50 centimeter, and when this is this moment, and this is clockwise, so clockwise moment, so clockwise moment equal to 50 centimeter into 50 gram force. Gram force is an unit of force, gravitational unit, clockwise. And the anti-clockwise moment, anti-clockwise moment equal to x into 100. So x means x centimeter into 100 gram force. So when, according to principle of moments, according to principle of moment, so students, according to principle of moments, and this is 50 centimeter into 50 gram force, because the clockwise moment is equal to the anti-clockwise moment, and this is called principle of moment. So 50 into 50 gram force, this is x into 100, because this is x into 100, and so x equal to 50 into 50 divided by 100, so this is 25 centimeter. So the answer is you can write the answer at this is 25 centimeter from one end, because this value is 25, so this is from that particular ones to the knife edge, it is 50 centimeters, so this one is 25, and this is also 25. So you can write the from the fulcrum it is 25 centimeter, or from the one end it is 25 centimeters. So let's check the answer. So to check the answer is at 25 centimeter from the other end. So this is the one end and this is the other end, so from other end it is 25 centimeter. Is it clear? So students, that is we have completed 80, and this is concise physics, so you can follow it. It is a very much conceptual book. So at a distance 25 centimeters, this is the last questions, and I hope you all think that this is a more and more conceptual channel. So please subscribe it and wait for the next class, that is start from 9, and little more concepts about it is given, and that is the kinds of equilibrium. So equilibrium of bodies, this will be start for the next classes. Equilibrium of bodies, that is what are the different kinds of equilibrium. And so thank you students, and welcome for the next class. Bye.